In this video, we're going to do some quick work solutions to initial AS assessment on algebra and number. In the first question, we're asked to solve the equation 2 multiplied by the quantity x minus 3 is equal to 1/2 multiplied by the quantity x plus 2. So we have a linear equation and we need to solve for x. What I'm going to do here is multiply the brackets on both sides of the equation. So we're going to have 2x minus 6 on the left, and then on the right we're going to have 1/2 x plus 1. I'm going to add 6 to both sides and subtract 1/2 x. I'm going to keep now my value of x as a fraction rather than a decimal. So I'm going to get 3 over 2x is equal to 7. At this stage I'm going to divide both sides of the equation by 3 over 2. Dividing by 3 over 2 is the same as multiplying by 2 over 3. So I'm going to end up now with 14 over 3. We would leave our answer as a fraction rather than trying to convert it to a decimal. So our final answer is x will be equal to 14 over 3. In the second question, we're asked to solve the equation x squared minus x is equal to 12. I'm going to subtract 12 from both sides and write this now as a quadratic equation in the form ax squared plus bx plus c is equal to 0. So x squared minus x minus 12 is equal to 0. I'm going to look to factor this, and we can do. So double brackets, we're going to have now x minus 4, and then we're going to have x plus 3 is equal to 0. So our solutions, x will be equal to 4, or x will be equal to minus 3. In question 3, we're asked in part A to find the coordinates of the minimum point of the graph y is equal to x squared plus 2x plus 5. To do this, I'm going to complete the square. So I can write this now as y is equal to x plus half the coefficient of the term in x, which will be plus 1. We square the bracket and subtract away 1 squared. That's going to give me minus 1, and then I add the 5. So we can write in completed square form x plus 1 all squared plus 4. If we think about this as two different graph transformations, we can see now that this is a translation of 1 unit to the left and 4 units upwards. So we're going to have minus 1, 4. So if I just wanted to show this now as a position on a set of coordinate axes, we're going to have now the point here, minus 1, 4. So all I've done is taken the original x squared graph and translated it now horizontally and vertically. So we're going to have the point just here, that's going to be minus 1, 4. That now is the minimum point. In part B, we need to sketch the curve y is equal to x squared plus 2x plus 5, showing any points of intersection with the coordinate axis. So we've got a standard parabola, it's a positive parabola, so it'll open upwards. That's our minimum point. We will come round through the y-axis, and then now we will be symmetric about the line x is equal to minus 1. We need this point of intersection, that is where x is going to be equal to 0, so y will be equal to 0 squared plus 2 lots of 0 plus the 5, so we can say now that this point is going to be 0, 5. So that's the sketch now of the curve. In part C, we need to state with a reason the number of real roots to the equation 0 is equal to x squared plus 2x plus 5. This now is where y is equal to 0. We can see that there are no real roots. You can make reference to the graph. If we've got now real roots, this particular graph will either touch or pass through now the x-axis. So we can say no real roots, and we can state that that now is from the graph and that it doesn't cross the x-axis, or we can use the discriminant. The discriminant, when a quadratic is in the form ax squared plus bx plus c is equal to 0, is given as b squared minus 4ac, and if this is less than 0, there are no real roots. So all I need to do is evaluate the discriminant. So two possible methods that you could use to show now that this has no real roots. If we look at the value of a, the value of a is 1, the value of b in our quadratic is 2, the value of c is 5. So b squared, 2 squared, minus 4 lots of a, which is 1, multiplied by c. 4 minus 20, that's going to give us now minus 16, therefore no real roots. So that's another approach. So let's just put in here, no real roots. So two different methods. We can say that the graph doesn't cross now the x-axis, or y is equal to 0, or we can use the discriminant. In question 4, part A asks us to simplify 25 over 4 to the power of 3 over 2. So we need to take the square root of 25 over 4 and then cube our answer. The square root of 25 over 4 is going to give us 5 over 2. So I've taken the square root of 25, the square root of 4. We now need to cube the answer. 5 to the power of 3, or 5 cubed, is 125. 2 to the power of 3, or cubed, is 8. 125 over 8. In part B, we need to simplify 3p to the power of 0.5 multiplied by 9p to the power of minus 1. I'm going to multiply the numbers, which will give me 27. We have the same bases, so when we're multiplying with the same bases, we add the powers. 0.5 plus minus 1 will give me p to the power of minus 0.5. You could, of course, write this as 27p to the minus 1/2, or you could write it as 27 over p to the 1/2, or you could write it as 27 over root p. All of these would be acceptable forms. In part C, we need to simplify fully p squared minus 1 over 8q multiplied by 4q cubed over p plus 1. The first thing I'm going to do is recognise this as a difference of two squares and factor. So we're going to have p plus 1 multiplied by p minus 1. I can see that the 4 and the 8 are going to cancel. 4 divided by 8 is going to give me 2. I've got now q to the power of 3 divided by q. Using the rules of indices, we subtract the powers. That's going to leave me q squared. And then we have now a linear factor of p plus 1. The p plus 1s will cancel, so we can write this now as q squared multiplied by p minus 1 over 2. And that's one of the many ways that you could write that. You could write it as 1/2 q squared p minus 1, 1/2 p minus 1 q squared, but anything that simplifies to this form is perfectly fine. Okay, let's now look at question 5. In part 8, we need to write 3 over 2 root 8 in the form k root 2. We need our answer in the form root 2. This is root 8. We could now convert this at the start, or we could do it later. I'm just going to write that root 8 is going to be 2 root 2. So I'm going to now convert it at the beginning, and we have 3 over now 2 lots of 2 root 2, which is going to give me 3 over 4 root 2. I'm going to rationalise the denominator, so I'm going to multiply the denominator and the numerator by root 2. If I consider now the numerator, I will have 3 root 2. In the denominator, I'll have 4 times by 2, which is going to give me 8. So we can say now that k will be equal to 3 over 8. So that's our value of k. You could have just multiplied the numerator and the denominator by root 8 and then simplified from there. I've done it at the beginning. Okay, in part B, we need to write 3 lots of the quantity root 2 plus 1 over the quantity root 2 minus 1 in the form a plus b root c. We need to rationalise the denominator. I'm going to have 3, then I'm going to have now root 2 plus 1, and then in the denominator I'm going to have root 2 minus 1. I need to multiply the numerator and the denominator by root 2 plus 1. What I'm looking to do here is create the difference of squares in the denominator so we can write this as a rational fraction. If I now go ahead and expand, or rational denominator of a fraction I should say, if we expand the numerator, root 2 times by root 2 is going to give me 2. Then I'm going to have plus root 2 plus another root 2 plus 1. In the denominator, showing full workings, root 2 times by root 2 is 2. I'm going to have plus root 2 minus root 2 minus 1. We can see that these are going to cancel, and just tidying the numerator slightly, I'm going to have 3 lots of 3 plus now 2 root 2, and that's all going to be over 1. 2 minus 1 gives me 1, so we can say that this, now expanding the bracket, will be 9 plus 6 root 2. So that's my final answer, 9 plus 6 root 2. So A is going to be 9, B is going to be 6, and then c will be 2. So we found the values of a, b and c. Okay, let's move on to question 6. We're asked to find the set of values for which 4x plus 3 is less than minus 7, giving our answer as an exact fraction. So this is a linear inequality, and I'm going to subtract 3 from both sides of the inequality. So we'll have 4x is going to be less than minus 10. Dividing by 4, 4 is a positive number, so we don't change the sign round. We're going to have now, let's just divide it by 4, we're going to have minus 10 over 4. So minus 10 over 4. We're not asked to simplify this, but if we wanted, we could write this now as x is going to be less than minus 5 over 2. So we're asked to find now the set of values. X is going to be strictly less than minus 5 over 2. In part B, we need to find the set of values for which 2x squared minus x minus 1 is greater than or equal to 0. This is a quadratic inequality. That's going to factor. I'll have 2x plus 1 and then x minus 1, and that's going to be greater than or equal to 0. I'm now going to draw a little sketch with my critical values. My critical values are going to be minus 1/2 and positive 1. So if we put these on, there's minus 1/2, there's 1. So minus 1/2 and 1. I'm now going to draw a parabola. I've got a positive parabola. We're interested now where this is going to be 0 or greater. We can see it will be to the left of minus 1/2 and to the right of positive 1. So we can say that x will be less than or equal to minus 1/2, and we're going to have x is going to be greater than or equal to 1. And that now gives us the set of values for which 2x squared minus x minus 1 is going to be greater than or equal to 0. Okay, let's look at question 7. We're asked to solve the equation 2x squared plus 3x minus 4 is equal to 0, giving our answers as exact values. That suggests that I can't factor it, so I can either complete the square or use the quadratic equation. I'm going to complete the square after I've divided the equation by 2. X squared plus 3 over 2x minus 2 is equal to 0. At this stage I could add 2 to both sides. All I'm going to do is complete the square now on the x terms. So we're going to have x plus half the coefficient, which will be 3 over 4. We square the bracket and subtract away 3 over 4 squared, which is 9 over 16. I'm just going to rewrite this now as a fraction over 16. That will be 32 over 16. You certainly don't need to do that, as you might already have it on the right hand side. So I can write that x plus 3 over 4 all squared will be equal now to 41 over 16. I've simply added the fractions and added to both sides. Taking the square root of both sides, x plus 3 over 4 will be equal to plus or minus the square root of 41. 41 is a prime number, so we can write it as root 41 over root of 16, which is 4. So our solutions now are going to be x is going to be equal to minus 3 plus or minus the square root of 41 over 4. I've simply subtracted the 3 over 4 from both sides and written this now with a common denominator. You don't have to write it in that way, but this now gives us the exact solutions. Okay, in part B we need to complete the square for the expression 5x squared plus 15x minus 2. If we're completing the square, we need to ensure that the coefficient on the term in x squared is 1. So taking 5 out, we've got x squared plus 3x minus 2 over 5. I'm now going to complete the square within the bracket. So all I've done here is taken the 5 out, and we're going to complete the square. So I'm going to have x plus 3 over 2. I'm taking half the coefficient. I'm now going to square the bracket and subtract away this number squared. If I subtract away that number, that's going to be now minus 9 over 4, and then we're going to have now the minus 2 over 5, so minus 2 over 5. Again, you might decide not to take this value in when you're completing the square. That's perfectly fine if you don't want to do that. All I'm going to do here is combine the fractions. So what we're going to have, and just combining the fractions, we're going to have x plus 3 over 2 all squared, and we're going to have now minus 45, and then we're going to have now minus 8, so that's going to be minus 53 over now 20. So all I've done is combine those, multiplying back through by the 5, we'll have 5 lots of x plus 3 over 2 all squared minus 53 over 4. With that one, lots of different approaches. This is our final answer, and you can deal with this constant however you like. So you might just leave the 2 out. Looking at this one, it probably would have been easier to leave the minus 2 out here. All I've done is completed the square inside the brackets, combine the fraction, and multiply back through. So if you like, you could have said now 5 lots of x plus 3, so x squared plus 3x, and then you would have had the minus 2. Looking back, that would probably be easier. Complete the square here and then deal with it from there. Okay, so that's now part B done. In question 8, we're asked to solve the simultaneous equations xy equals 32, x squared plus y squared is equal to 80. I'm going to call this one equation 1 and rewrite it. I'm going to say now that x is equal to 32 over y. So all I've done is rewritten now x in terms of y. I'm going to substitute that into equation 2. So what we've got then is x squared. So we can write this now as 32 over y, which we need to square, plus y squared is equal to 80. And I'm just going to write this now as minus 80 is equal to 0. So I've just subtracted. Okay, if we square 32, 32 squared will give us 1024 over now y squared, which is y squared, plus now the y squared, minus 80 is equal to 0. I'm going to multiply the equation by y squared, so we have 1024 plus now y to the power of 4 minus 80y squared is equal to 0. I have a quartic equation, y to the 4th minus 80y squared plus 1024 is equal to 0. Now we can factor this like we factor a quadratic, or you could use a substitution and let p be equal to y squared. So if we did, we would have p squared minus 80p plus 1024 is equal now to 0. We can go ahead and factor this. If we factor this, we've got p, and that's going to give me now p minus 16 multiplied by p minus 64 is equal to 0. So we can see from here that p will be equal to 16 or p will be equal to 64. We now bring the substitution back if you made the substitution. You could have factored this now, and I'll write it just here, as y squared minus 16 multiplied now by y squared minus 64 is equal to 0. I personally prefer this method as we've got now an expression for y squared. So if we look at this, we can say that y squared is equal now to 16. Therefore, we can say that y will be equal to plus or minus the square root of 16, and that will give us plus or minus 4. Our other solution for y squared is 64. Therefore, we can say now that y is equal to plus or minus the square root of 64, which is 8. What we now need to do is sub in and solve for x. So we have our values of y. We've got 4 possible values of y, and I'm simply going to take the equation just here and solve for x. So if we consider now x, let's just write x here. I'm going to take now y is equal to 4. So when y is equal to 4, and I'll write it just here, y is equal to 4, we've got now that x will be equal to 32 over 4, and that's going to give me 8. When y is equal to minus 4, we've got x will be equal to minus 8. If we take now y to be equal to positive 8, we're going to have x will be equal to 32 over positive 8, which is going to give me 4. And then if we have y is equal to minus 8, we'll have x is equal to minus 4. Now, of course, you can just express these when y is equal to plus or minus 4, x is equal to plus or minus 8, and then when y is equal to plus or minus 8, x is going to be equal to plus or minus 4. So there are our 4 solutions. Now, if we just look at this, we can have a quick look at these 2 equations. This is going to give us a reciprocal graph, and this is going to give us a circle. So what we have here is a circle. This is a circle with an equation now of x squared plus y squared is equal to 80. That tells me that it's a circle with a radius of the root of 80. So what we're going to have is something that looks like this. The centre is going to be at the origin, and then we're going to have now a reciprocal graph. xy is equal to 32 will look something like so. And we could write this now, let's just jot that. We could write this here, and this is a really quite a rough sketch. We could write this now as y is equal to 32 over x. So that's the graph that I've just drawn. We can see 4 points of intersection. That one will be here, one just here, one just here, and one just here. So if we consider now, this is going to be the point just here, which will be 4, 8. X is 4, y is 8. This is going to be now 8, 4. This one is going to be minus 8, minus 4. And this is going to be minus 4, minus 8. So the sketch isn't very accurate, as you can clearly see, but this gives us some idea of what these equations would look like. Hence the number of solutions that we've got to them. So if you've got it in this form, you can simply use these values right here, plus or minus 4, therefore plus or minus 8, plus or minus 8, therefore plus or minus 4.